Hey, this is Mr. Win. Today's video will be about parent functions and transformations. Note that this is one of the most important algebra topic lessons, and it'll come back over and over throughout the whole year, even next semester. So first, you need to memorize the four parent graphs or functions. Remember that a parent function is the simplest equation for that type. You can only have y equals x to some exponent. You can have any numbers, you can't add, subtract, multiply, divide. So y equals 1 is a special case. That's y equals x to the 0 power. Y equals x to the first power is the identity or linear one. Y equals x squared is the quadratic parent. And you have the absolute value of x. That's the absolute value parent. Make sure you know the shapes. Constant is left, right, horizontal. Linear is diagonal. Quadratic is a u. Absolute value is a v. So I like to think of it like this. If it's constant, you have a power of 0. Remember, anything to 0 power is just 1. You can use a calculator, check that. And it's just a horizontal straight line. If you have x to the first power, that's linear. We usually don't put that 1 there. If it's invisible, it's a 1. You know that. That's a diagonal line. You draw it all the time. Quadratic means power of 2. So y equals x squared. And that's a u shape. And then absolute is y equals absolute value of x. And that's a v shape. So for example 1, identify the type of function family for each graph, then write the parent function. So A, that's a V shape. If it's a V shape, we know that's the absolute value family. So absolute value. So that's in the absolute value family. Now what's the parent function for absolute value? That's just y equals absolute value of x. That's not the graph, because that graph's moved around a bit, but that's a type of absolute value. All right, B, that's just a straight diagonal line. I know that's a linear graph. The parent function for a linear graph is just y equals plain old x to the first power, which we don't have to write the power. C, that's a constant function. This is left and right. We're not going diagonal. So I write constant. And the parent for that is just y equals 1. You don't say y equals 4. That's the line. That's just y equals 1 moved up. And D, that's a U shape. All U shapes are quadratics. So that's in the quadratic family. And the parent function for quadratic, the simplest quadratic equation is just y equals x squared. No adding, subtracting, multiplying, dividing, and no negative numbers. All right. Now you need to memorize the 3 types of transformations. So I always think about is the letter or the number stuck with x, like dealing and involving directly with x, or is it by itself? Away from x. So this first thing says f of x plus h. That h is inside the parentheses stuck with x. X, y'all know, controls left and right on the coordinate plane. So this moves left and right. When I say plus h, it's actually the opposite. That means move left h number of units. So if that was x plus 5, that means I move left 5 units. So on the opposite side, if of x minus h in parentheses stuck to h, stuck with x, that means I move right h units. So if that was a x minus 8, that means I go right 8 spots. This next one, f of x plus k. K is by itself. It's not stuck with x. So that's y. Y controls up and down. And the nice thing for this is you don't do a reverse and the opposite. If it's positive, that means you go up. So you go up k units. And if it's fx minus k, and k is just a number, and it doesn't change signs, that just means down k units. All right, reflections is a flipping left and right or flipping up and down. So first I have negative f parentheses x. That negative is outside the parentheses, not bothering x. So that's really a y thing. That means it's flipping up and down, usually just flipping upside down. So flip upside down. And I'll show you these in calculator to verify. And this next one is stuck inside with x. That means you flip left and right. Flip left or right, really. Flip left or right. It really doesn't matter which one you choose. All right, and the last one, dilations. This makes the graph either wider or fatter, or taller and skinnier. The correct words are usually vertically compressed or vertically stretched, but I like wider and taller. So A is in front of f of x, so it's not stuck with x. If A is bigger than 1, the absolute value of A is bigger than 1. So it doesn't matter if it's -5 or +5. If that's bigger than 1, that's going to make the graph taller and skinnier. All right. But if it's between 0 and 1, absolute value means like a fraction, that's going to make the graph wider or fatter, your choice. All right, and b of x, that's stuck with b, it's stuck with x inside. That's going to, again, if it's bigger than 1, it's going to make the graph taller or skinnier. It's both. And if b is between 0 and 1, meaning a fraction, it's going to make the graph, again, wider / fatter. It's nice, so wider. And I'll show you how to use this in the next slide. So, describe the transformation in each function and graph it. Also identify the domain and range. Part of Algebra 2 is graphing these without using a calculator. That's why we learned the parent functions. So, A, it says absolute value of x plus 2. I know the parent function is y equals absolute value of x. Every other number that's there, I need to talk about and figure out what to do with it. So I see that plus 2, oh, let me draw this. Here's the original graph of y equals absolute value of x. Here's the parent function. It should be about 45 degrees. That's normal, all right? That's not our blue line, though. That's not A. That's just the red line. This blue line looks almost like my red line. So it has a plus 2 at the end. That is not with, like, stuck with x. It's not trapped inside the absolute value with x. That's the y thing. If you add 2 at the end, that just means move up 2. That's changing the y-intercept. So this blue line is really my red line up 2. So really I start right here, and let's draw the same slope and everything. So that's the blue line. And that's at y is 2. Because everything usually starts at the origin, 0, 0. All right, tell me domain and range. The domain of my blue line, the A, domain x, it goes left to infinity, right to infinity. So negative infinity to positive infinity, or all reals, your choice. The range, how low to how high. The lowest the graph goes is a 2. It counts 2. The highest it goes is to infinity. You can also say y is greater than or equal to 2. B, again, the parent function is y equals absolute value of x. It's a V shape. I have a negative in front. That's not stuck with x. That's in front of it. So that's a y thing. Remember, the negative sign just flips up and down. So if my original graph looks like this, again, that red line should be at a 45-degree angle. That's the same red line from before. I'm just now flipping it upside down. So this blue line is this. All right, for this blue line, again, the red line is just like a shadow to let you see the original and like the before and after. The domain, how far left, how far right? Again, negative infinity to positive infinity. The range, how low to how high? It goes down all the way to negative infinity, and how high? It goes up all the way to 0, and it includes 0. So you could say y is less than or equal to 0 if you want, because 0 is the point origin. All right, C, it says y equals 1/3 x squared. I know that's parent function is x squared, quadratic. So here's the quadratic graph. Looks like that. It makes a U. Now the only difference here is there's a 1/3 in front, and that's in front of x squared. That's not stuck inside it. Otherwise, it'd be stuck with the exponent. So when there's a third, that makes the graph wider, fatter. So I'm going to draw a really fat U. Now this time, I guess, let me use a calculator to show you that I'm right. So in the calculator, I'll graph the original x squared, and then I'll graph the new one, and I'll make it bold for y'all. So alpha y equals 1, oops, wrong spot. Alpha y equals 1/3 x squared. And you'll see the bold line is fatter. So here's the original, that red line I made, and then here's the other one. See how it's wider and fatter? I could do the other ones too, but I'll do that later. So for this blue line, the domain, how far left, how far right, it goes left forever, negative infinity. It goes right forever, positive infinity, or all reals. For range, how low to how high, the lowest is still 0, 0. It includes 0. How high, it goes up forever to positive infinity. So that could be y is greater than or equal to 0. In this last one, D, I still see x and I see squared. I still know that's a quadratic. So still the family of the parent function is x squared. The difference is that plus 3, that's stuck inside with the x. So I know something left or right. Remember, it's opposite if it's stuck inside with x. So I know this is my original, this red graph is the original parent function. Should be the same thing as C. Now, if it's plus 3 with x, actually means minus, it means left 3. So everything in my graph is going to move left 3 units. So instead of being at 0, 0, which it should be at, right there, I'm going to move it left 3. So 1, 2, 3. This is where it starts. That makes the exact same U. It shouldn't be wider or taller. It should be exactly the same. So now I do my domain and range. It goes left forever. It goes right forever. So all reals. My range, it goes, the lowest is 0 and the highest is still infinity. Alright, so let me show you that on the calculator. So that original line is x squared. This bolded line will be parentheses x plus 3 close parentheses squared. You'll just see the same line, just move 3 to the left. So this is my u, there's my other u. Alright, and the last example, you can do a combination of all of them, translation, reflection, dilation. So describe the transformation in the function, also graph it, and identify the domain and range. So here I see a quadratic. So y equals x squared is the original. It should look like this. Now every number I see I need to talk about. So first I said negative 3 in front. Well, negative means a is negative. Negative means flipping. So that negative, say a is negative 3. Negative means flip upside down. And then if a is a number that's bigger than 1, remember it's 3, that makes it taller and skinnier. Taller slash skinnier. It's the same thing. So just not wide, not fat. Or I see that minus 5 inside with x. Remember, it's inside the x, that means left, right, but it's opposite. So I know that minus 5 means right 5. I need to move right 5, or shift 5 units to the right. And that plus 4 at the very end, that's the y thing, not stuck with x. That means up 4. So when I graph this one, I'm going to start at 0, 0, where the other graph starts. I'm going to go right 5. So let me use blue. So 1, 2, 3, 4, 5. Up 4, 1, 2, 3, 4. So this is where my new u would start. And instead of drawing it normal up and upwards, it's going to be upside down. And then it's going to be taller. So it's going to be a really skinny, tall graph. It'll look like this. All right. Domain and range. Domain, left infinity, right infinity. Range, the highest it goes, or lowest is negative infinity. The highest it goes is positive 4. Includes positive 4. I'm going to show you that graph real fast to make sure I'm right. We have x squared, and then in bold, I have negative 3 parentheses x minus 5 close parentheses squared plus 4. Graph it. And there it is. So it's over there to the right, and it's going down and skinnier. All right, I'll leave you with this practice problem. Try. If you can get it right, you should be good for the quiz. Again, this is Mr. Witten. Thanks for watching. See you in class.